So okay, so in the previous class we were started discussing about the exact OD, so we will continue that one in today's class. So what exactly we studied in the previous class, if I will try to summarize in a minute, I can clearly say that if there exists a function u, okay, such that derivative of u x y is equal to m x y dx plus m x y dy. What is this u? U is the potential function, right? So that means what is the differential equation? So we can clearly say then the differential equation m xy dx plus dx plus n xy dy is equal to 0. So this one is called exact ODE when if double F, that means if and only if the condition is that dm by dy is equal to dn by dx. So if this condition is true, then this ODE is called exact ODE. Right? So this is what we discussed in the previous class, and I told you one way how to solve this problem. Right? Also, I stated an alternative method. So one way I told you that you need to start it using the using a potential function, then you differentiate that while keeping the y is constant, then try to find out the value of that constant. In that way you can calculate the value of y, value of u. That we studied. If you remember, we did that one here. We did that one here. That means we ultimately try to find out what is that u. Right? So also I mentioned about an alternative method that I told you, this one. So this is an alternative way to solve the same problem. So let's try to understand this one. What is this? If I will say, if the given ODE is this one, okay, if this is the OD, if this is the OD, and we found that this OD is an exact OD. Suppose we try to find out dm by dy and dn by dx, and we found that the OD is an exact OD. Then the alternative solution method is very simple, that we have to write the integration of m dx plus integration of n dy is equal to c with some condition. So what are those conditions? I will specifically write the condition. First thing, that here y is constant. When we will try to integrate with respect to x, consider y is a constant. Okay? If there is any y, we should treat as a constant. We do not play with that one. And the second one is the terms do not contain x. That means whatever may be the n value, whatever things are there, if there is any term where we have x, we can just exclude that one or consider that one as a simple zero. Okay, not bad. So we will take the same example and apply here. Which one? The same example we used in the previous case is, where is that one? Yeah, the same example we will take, this one, and we will try to use the alternative method to solve the problem. So what is the example? Same example. What is that? Cosine x plus y dx plus 3y square plus 2y plus cosine x plus y dy is equal to 0. So this is the OD, right? And we know in this OD, we already solved this one, that this one is our m and this one is our n. And we already know dm by dy and dn by dx. What is that value? And we found this one is minus sine x plus y. Right? So in this case, this is an exact OD. Right? This is one exact OD problem. And now we apply this trick method, simple method that I just told you. That means I will put integration of m, that is cosine x plus y dx plus integration of n, that means 3y square plus 2y plus cosine x plus y, and I will put here dy is equal to constant. The condition, I have the conditions. What is y is a constant, and here terms do not contain, sorry, do not contain do not contain x. So we'll try to solve this one. How we should proceed? What is the first one? Integration of cosine x plus y will be y is a constant here, right? So then what it should be? Simply sine x plus y, because y is a constant. Yes or no? Plus. Now if you notice in this one, this is a term of y, this is a term of y, but here in this term we have a x, right? So we simply ignore this one or treat this one as a 0. Okay? So when we integrate, we assume that this particular term is nothing but 0. Forget about it, because this is the term contain x. So whenever we found any term containing x, just ignore that one and continue the integration. Okay? So when you do this, what will be the value? Yeah, any question? Yeah, please. Any question? Yeah.
Can we swap the f and the n?
And?
So we differentiate by the x on the right side and dy on the left side. Can we do that?
But I didn't get your point.
Can we differentiate by dy on the left side and dx on the right side?
Can you differentiate?
I mean, can you move the dy to the left side and dx to the right side?
I'm not getting. What are you saying? Why?
How do you know which part is m? M be cos x plus y.
I already told you, whichever part is dx, that is m, whichever part is y, dy is the n. That is it. Initially I have defined. If you see in the beginning, I have defined here. M dx n dy. Yeah. When I define the first order ODE for this particular one, I clearly define which one is m and which one is n.
Then will the dx and dy be present on the question before we start?
No, you have to figure it out. Which one will be your m, which one will be your n.
Then how do we figure it out? Like there are lots of addition sign. How do we divide the m and the n?
Okay. Maybe I will put a question, you can understand that one. You can go. I will put a question for you, then you can understand. Okay, let's solve this one first. Okay, I got your question. Okay. Maybe I will take another example to clarify that one. Basically, when we give the OD, for simplifying, I put is dx dy. Okay. Actually, it should be come with the y dash. Y dash. So when you have the y dash, you have to keep the dy one side and multiply the dx in the other side. Then the part where the dx is multiplied, that will be your m, and the dy part is the n. So that is why I initially told that this is the exact ODE form. That means when your ODE will be m dx plus n dy. Okay, you got my point, right? So basically, you divide whole ODE into two parts. One part is multiplied with dx and the other part will be multiplied with dy. Then you have to clearly define this is my m, this is my n. Right? Clear? Okay. So come back to this solution now. Now this is my, I consider this term is 0. Now my focus of the integration is only this one. So if I integrate this one, so what I will get? Y cube plus y square is equal to 6. So now you can check what was the answer of the, when you solve in the original, the method that was given in your book. When we solved, what was our answer? You can check your notes previously. In the last class, we solved the same problem. What was your answer? Same? So that one was a very lengthy process, which is actually the right way should be done. Okay? And this one is a tricky method, like what you can say, shortcut. Okay, this was not given, this one is not given in any book. Okay, you will not found this trick is any book. Okay, but there are some shortcut method to do. Okay, like if I will ask you what is the square of, let's say, 25. Okay, there is some shortcut way to calculate. Okay, large number, like if I will ask you what is the square of 99. Okay, if there is a, you need to find out the square of 99. What? You have to multiply 99 with 99. There is a shortcut method to do that. Right? Similar thing. This is a shortcut method. Okay. You can also use this method to solve the problem. Okay. Yeah. Okay. So now let's quickly solve few problems on this exact OD, then we'll move for the problems which are not exact OD. Okay, so quickly solve some problem. Okay, so here is your first problem. y dx plus x dy is equal to 0. Y dx plus x dy is equal to 0. Solve this exact ODE. First test the exactness and solve it. The question should be in this way. Test the exactness of the ODE and solve it. Y dx plus x dy. So you can clearly see which one is your m and which one is your n. So this is your m, this is your n. So calculate dm by d, sorry, dm by dx dm by dy and dn by dx. How much? One. So this is one exact ODE. Just solve it and tell me the answer. What is the solution? Yes? xy is equal to c. Yeah. So, as you mentioned, it is y dx plus 0 dy is equal to c. So this one will be yx is equal to c. So this will be your answer. Why I put 0 here? Because there is a term x. That's why I put 0. Even if I will not put anything, that's also fine. But if you will not put 0, then it will be treated as 1. Yes or no? Because any term with x should be treated as 0. If I will not put 0, just dy means it will be treated as 1. Then it will give you a value y. Okay? Okay, one more question here. Question number 2. 1 plus 2x y cube dx plus 3x square y square dy is equal to 0. So this is my m, this is my n. problem. Yeah, tell me dm by dy, dn by dx. Yeah, both are I think 6x y square, right? Then you have to, since it is, if this is, then this is an exact OD. If it is an exact OD, then the next thing is you have to apply the solution method to solve it. How to do that? Integrate 1 plus 2x y cube dx plus integrate 3x square y square dy. Here is y is equal to constant. Here is no term with x is equal to constant. So basically, in this case, what will happen? This one will become 0 because there is a x available. So this term will be the right hand side term right after the addition operator will be 0. So we'll just left with the term with where y is a constant. If we integrate that one, how much y we will get? We'll get x plus how much? X square y cube is equal to x. Yeah, so simple. Okay, so let's try one more. E to the power y dx plus x e to the power y plus 2y dy is equal to 0. So this is my m and this is my n. Test the exactness. Are they exact? dm by dy dn by dx. Are they exact? Yes. Yes or no? They are. Right. Now, of course, applying the solution. Are you okay with the exactness or any doubt? They are exact, right? Are they exact or no? Yes. So why no reaction from you guys? Okay. So if they are exact, now let's go for the solution. That is e to the power y dx plus x e to the power y plus 2y dy is equal to constant. Y is a constant here. And here no terms with x. If there is any term with x, you can treat it 0. Right? That means I can rewrite now this here, particularly the first term, this term will be 0 because there is x. Yes or no? So we're left with only 2y. So I can now now I can write e to the power y dx plus 2y dy. Here is y is a constant is equal to c. Then tell me the answer now. X e to the power y plus y square is equal to c. Okay. Now similar problem may be given as a initial value problem. That means a small condition will be provided. That will be the initial value problem. In that case, you have to find out the value of y. Value of c. Like suppose in this the same problem, some initial value will be given like suppose I will give a condition here y, what is the condition? Is equal to, let's say I will put 1. Suppose this is the initial condition given, the same problem. Y0 is equal to 1. That means if we take x is equal to 0, y is equal to 1. The same problem. I'm talking about an initial condition I am putting. Then this problem become an initial value problem, right? So what I need to do now we can treat this problem is a general solution or generic solution. So I need to find out the specific solution. That means I can treat x is equal to 0, e to the power 1 plus 1 to the power 1 square, because y is 1 now, is equal to c. That is giving me c is equal to 1. So then the specific solution will be x e to the power y plus y square is equal to 1. This is a particular solution. Yeah. Any problem? Is it okay? Okay. So I gave you a brief overview about the exact ODE and what kind of problem you can face, both generic as well as particular or initial value problem. Now the question is that because we test dm by dx is equal to dn by dy is the condition when the ODE is an exact ODE, right? The condition we tested that all these problem we always test what? This condition dm by dy is equal to dn by dx. And if they are equal, then we say that this ODE is an exact ODE. And we apply the method to solve it. Now the question is, if we found a ODE in the similar form, if we found a ODE in this similar form, that means the exact ODE form, okay? But this dm by dy is not equal to dn by dx. If they are not equal, then what will happen? Right? Let's discuss that. Okay? Now let's discuss that one here. In the ODE, m x dx plus n dy is equal to 0. This is the ODE. In this ODE, if dm by dx is equal to dn by dy, then we say it is an exact ODE. right? So this one we just studied. Now, if dm by dx is not equal to dn by dy, if they are not equal, yeah. Oh yeah, sorry, it's a mistake. Okay, yeah. Thank you. Yeah, dm by dy, because m with x, so we have to divide with y. Yeah, thank you. So dm by dy is not equal to dn by dx, then it is not an exact ODE. It is not an exact ODE. Okay. So solution method is same. We have to apply the same method we used for the exact ODE. But first, our job is to convert this non-exact ODE to an exact ODE. Okay. So now our job is to convert this non-exact ODE to exact ODE. Okay. So if you remember yesterday, I mean not yesterday, in the previous class, I told you another term. Yeah. Anybody remember? Another term I told you. With exact ODE, I told you another important term in the previous class. Yeah, anybody remember? You are not reviewing whatever we are studying in the class.
Factor?
Yeah?
What factor?
Yeah. What was that? Some factor. Integrating factor. Okay? So that is what we are going to use now. Okay. So now the ODE we have is this one. M dx plus, I'm just for simplifying it, I'm not putting every time xy with the m and n, okay, because it is the same function, okay, plus n dy is equal to 0. So this is our ODE, okay. So now what we need to do, that we have to multiply one function with this ODE, okay. So that function, let's say that function is mu. Mu is the another function we are going to multiply with this, okay. So when we multiply, this one become mu y m x y dx plus mu x y n x y dy is equal to 0. Now what is this mu? So that mu is actually, we called a special function that we called this mu, we specially called something called integrating factor. Integrating factor. Integrating factor mu is a special function that we use to convert a non-exact ODE to an exact ODE. Okay. So this integrating factor is a special function that we use to convert the non-exact ODE to an exact OD. Now, after multiplying this one, now this, when you multiply, let's say we got, this is mu into m, so that is, let's say we found something pxy, dx plus qxy dy is equal to. Now we have to choose that mu in such a way that, so that when we will rewrite the equation in this form, px and plus px dx, sorry, p dx plus q dy is equal to 0. So this is our new ODE. So this ODE have to be an exact ODE. Then what should be the condition to be this ODE to be a exact ODE? The same condition that we had previously. What was that? There we have dm by dy is equal to dn by dx, right? So here the condition is that dp by dy is equal to dq by dx. If this condition satisfied, then this is an exact ODE. If this condition satisfied, then this new ODE is become an exact ODE. Okay. Now the next thing is that how to get this integrating factor. Okay. So let's take a break, then we'll discuss that one. Yeah, you can stop this one. So this is what exactly we are looking for. Is that when an ODE cannot be converted, when we test the ODE and we found that the ODE is not an exact ODE, we need to find out a function. That function is called integrating factor. What we need to do, we multiply that integrating factor with the ODE, and then whatever value we found, that f, the f term or the term m, we need to find out a new term m, that is called the p. Same as for n, a q. Then we try to check whether db by dy is equal to dq by dx. If they are, we called it exact. And the solution method for this ODE is pretty much same. That means earlier it was, now to solve this ODE, what do we need to do? The p dx plus q dy is equal to c, and here y is constant and terms do not contain x. Just like the previous case, the solution method, right? Now the next question is how to find out that integrating factor. How to find out that integrating factor. So here is the method. methods to find integrating so first one is method of inspection. That means you have to look into the problem and try to figure out maybe some kind of estimation in your mind, and you can think which one will be the best one. Okay. Second one, the integrating factor, let's say we are considering the integrating factor as mu. Okay. Second case is mu is equal to 1 over mx plus ny, m into x plus n into y. Third one, mu is equal to 1 over mx minus ny. Fourth one, mu is equal to e to the power integration of fx dx, e to the power fx dx. Where your fx is equal to dm by dy minus dn by dx divided by n. Fifth one, mu is equal to e to the power integration minus fy dy. Okay, where fy is equal to dm by dy minus dn by dx divided by n. Yeah, little bit observe the terms, and we will continue. Okay. Fair enough. So let's try to solve some ODs that are not exact OD. First thing that whatever OD is given, you have to check whether they are exact or not. If not, then you have to find out the integrating factor to make it exact. Okay. So let's take some example. Here is the first one. X dy minus y dx is equal to 0. This is my 2D. Yeah, tell me what is my n? What is my n? That means I need to calculate the m by dy dn by dx. Are they exact? Are they exact? No? Why? What is my n? What is n? What is n here? M is what? Which one is my m? Minus y. Yes. First thing that many times student encounter of the term that is first is n, the term that is second in the m. No. First you need to write the OD in that form. That means you can first find out it in original form. That means it should be minus y dx plus x dy is equal to 0. So then this is my m and this is my n. So most of the students used to make this mistake. They consider the first term is m, the second term is y, and they try to solve it. And consider that yes, it is an example. First you need to figure out which part is n. Okay, m that is with dx, n that is with dy. Okay. Okay, so the dm by dy and dn by dx. So this one will be minus 1 and this one will be 1. So they are not exact. So when they are not exact, what we need to do? We have to look into something called integrating factors. Okay. So here, if we, by method of inspection, we can figure it out. One of the integrating factors, or the one integrating factor we can figure is 1 over x squared. Actually, there are many ways to figure it out, the integrating factor. One is the method of inspection. When you practice so many problems, you can easily, by looking into the problem, you can easily figure it out. Oh, for this problem, I think this one will be the integrating factor. And the other way is that you have to look into the methods that is given. And in some cases, the integrating factor is usually given in most cases, in the book. When the problem is given, they give the hint, like, yeah, you can consider this one as the integrating factor. Sometimes the integrating factor given as a hint. Okay. Now, the next thing is, if we take this one is our integrating factor. So if you multiply this integrating factor mu with the ODE, so the ODE become minus y. That means I want right. If we multiply the integrating factor with the OD, that implies my OD is now become minus y plus minus y dx x square plus x by x square dy is equal to 0. That implies it is, I can say, minus y dx plus x inverse dy is equal to 0. So for now, in this OD, this is my P, this is my Q. Yes? Right? So in this, now I need to test that whether dP by dQ, sorry, dP by dy is equal to dQ by dx or not. So dP by dy and dQ by dx, how much? dP by dy is how much? Right? And this one, dq by dx, also the same. That means they are equal. That means this is now an exact ODE. So if this is an exact ODE, then what is my job next? Apply the solution. P dx. What is P? P dx plus Q dy is equal to c. Here y is constant, and here no term with x. Right. That means, what is my p? Minus y x to the power minus 2 dx plus x inverse dy is equal to constant. So in this, y is constant, and here no term with x. That means this one will become 0. So we left with the only one term. Now if you integrate this one by keeping y as a constant, how much we will get? Y by x is equal to c. Okay. So the way the number of students in the class is continuously reducing, so I can think about stopping the recording of the class. Yeah. That is the only way to attract student to the class. Yeah, since some student intentionally, okay, professor will record and upload, so no need to go. Yeah, that is why if you see how many students, 30% students are present, possible. Out of 80, how many? Very few, not half. That is counting. How many? Did you count? Yeah. How many? Okay. Next one. There was another foreign student with you, Indonesian. You from Indonesia.
Yeah,
There was another one.
just now the person is us in front of you.
Is not present.
The one who asked you is the same.
Oh, okay. That guy. Okay, so let's come back to the class here. Next question is, let's say, are you with your Himanshu, are you with your charger?
Yes.
I forgot to bring. Okay. X square plus y square dx minus 2xy dy is equal to 0. Okay, so this is our OD. How to solve this? So, what is your M and what is your N here? This is N, this is N. So dm by dy, dn by dx. So if you calculate, this one will be 2y, this one will be 2 minus 2y, right? Yeah. So they are not exact. So in this case, we can apply the one of the method to calculate the integrating factor is mu is equal to e to the power fx dx. Now what is our fx? We already know. dm by dy minus dn by dx by n. So when you calculate this one, how much? This is 2y minus 2y divided by minus 2xy, which is giving you minus 2 by x. So then, what is your mu? E to the power integration minus 2 by x. When you solve this one, it will be e to the power minus 2 ln x. That is e to the power ln x to the power minus 2, or simply x to the power minus 2. problem? Which one? Your question is why I choose this integrating factor method. There is no reason I could give you. Yeah. When you practice more and more problems, you have to figure it out which one could be the appropriate method to choosing the integrating factor. Literally, I don't know. That's why I told you, there are many occasions integrating factor will be given. There are many cases. Yeah.
Why x in the power of -2 equal to 2 by x? Isn't it 1 by x squared?
Which one are you talking?
X the power of -2 equal to 2 by x. Isn't it 1 by x squared?
Oh yeah. Sorry, it's a mistake from my side. Okay, sorry. Yeah, that's right. This one. Yeah, thank you. Yeah, it's a mistake from my side. So this one is your integrating factor. Now I gave you your integrating factor. Now you give me the solution. Yeah. Solve it and give me the solution. All of you getting it, right? How to solve this one? Yeah, if you don't know, then you can ask me. I think I already give you enough ideas how to solve it. Got it? Yes? Say it again, x minus two power of, okay, y power of 2 by x is equal to c. Yeah, that means you can rewrite this one as x square minus y square is equal to cx. Right? Is it the same answer for all of you? Or I have to solve it? Okay. Any confusion? Okay, let's check it step by step. So what is your P? After multiplying the integrating factor, what is your P? Yes, 1 plus this much. What about your Q? Minus 2y by x. All of you getting the same thing? Yeah, if you are getting the same thing, if you just apply the same method, like 1 plus y square x inverse dx plus minus 2y x inverse is equal to c. So here y is constant at no term with x. Then this term contain x means this one become your 0. So you will left with x. Your focus will be this one, where y is a constant, right? Yeah, so it is just x minus y square. So minus minus it will be plus. Oh, sorry, it was actually plus, so it will become minus. Minus x inverse is equal to constant. Yeah. That means you can write x square minus y square is equal to cx. Okay, very good. One more. E to the power x plus y plus y e to the power y dx plus x e to the power y minus 1 dy is equal to 0. And this one is a initial value problem where y0 is equal to minus 1. So, firstly figure it out. This is your m, this is your n, and if you clearly check your dm by dy and dn by dx, are they equal? Hopefully not. Yeah, what is dm by dy? What is dm by dy? E to the power x plus y plus yes y e to the power y plus e to the power y. And dn by dx is just e to the power y. So they are not equal. Now you can see that what is your dm and dy. From there you can think about which one could be your suitable integrating factor. Now if you look into this problem, my pick is this one. My integrating factor mu is e to the power minus f of y dy. Now you can ask why? Because if you look into this, my f of y is dm by dy minus dn by dx by m. And if you have already calculated dm by dy, that is e to the power x plus y. Who said y? Figure it out why? Yeah. So that is exactly we need to do. Because our approach should make it simple. So we need to figure it out which one we should pick to make it simple. E to the power xy plus y e to the power y plus e to the power y minus e to the power y by m e to the power x plus y plus y e to the power y. So ultimately, how much it is? 1. Because this is, and this, and this. Ultimately, I am getting 1. So if this one is 1, then my integrating factor mu is how much? E to the power minus 1 dy is e to the power minus y. Now look into the original problem, and if we multiply minus e to the power minus y, then how simple the ODE will be. That means if I write the original problem, e to the power x plus y plus y e to the power y dx plus x e to the power y minus 1 dy is equal to 0. So simply I have to divide here e to the power e to the power y. Now when the point I divide, it will try to several values to cancel. Like this one will be cancelled, this one will be cancelled, so is this one will be cancelled. That means I can simply write my new OD will be e to the power x plus y dx plus x minus e to the power minus y dy is equal to 0. So this is my new OD and this is my P, this is my Q. So then you have to just calculate dt by dy and dq by dx to check whether they are exact or not. So if I do that, dp by dy and dq by dx. If I will do that, how much? dp by dy is 1. dq by dx is also 1. So this is one exact OD. Now the next step is apply the solution method. Apply the solution method. That means integrating e to the power x plus y dx. Y is constant plus x minus e to the power minus y dy. No term with x. That means this term becomes 0. So is equal to c. So if I will integrate this one, y is a constant. What will be my value? E to the power x plus yx plus e to the power minus y, because this term will be 0. So we have to only integrate this one, right? So we'll get this is c. right? So you got this one. This is the general solution. Now, when y0 is equal to, what was the condition? -1 or 1? -1. Initial value condition. y0 is equal to -1. That implies when x is equal to 0, y is equal to -1. You just need to put these values to find out what is the value of c. Okay, so you can solve it now. So if you solve this one, the c value I got is 1 plus e. So my ODE final solution is e to the power x plus yx plus e to the power minus y is equal to 1 plus e. So this is my specific solution or particular solution. Thank you very much. See you in the next class.